Welcome to another video on digital electronics. In this video, we'll be seeing what are Kmaps and how we can reduce our equations so that we get the reduced form of equation for implementation. So Kmap stands basically for Karnoff maps. In short form, we call it as Kmaps. So for us, we can have either a 2 variable or a 3 variable or 4 variable Kmap. 5 variables, 6 variables are also there. But for the syllabus, we have restricted it to 2 variable, 3 variable and 4 variable. So let's start by 2 variable. For example, I have say A and B. So if I have 2 variables, then I have 4 different combinations, right? So how do we represent a K-map? I have a box. It is basically a graphical form of representation in which I'll have 4 other boxes. This is A and this is B. A and B both can have different combinations. So A could be 0 or A could be 1. Similarly, B could be 0 or B could be 1. So the first box that you see here where A is also 0 and B is also 0, if I represent using an SOP form, remember we did it in a canonical form for a reason, because in K-map we have to consider all the variables which are available. Hence, we write it in a canonical form. So, every term of a canonical SOP is a min term. So, in an SOP, we'll here represent a min term in this K map. So, A is also 0 and B is also 0, which means I have here A bar, B bar. A is 0 in this box and B is 1, which means I have A bar, B. Here I have A, B bar. A is 1 here and B is 0 here. And the last one I have both 1, 1, which means I have AB. So if I have AB, how do we write the truth table? 0, 0, 0, 1, 1, 0 and 1, 1. So if you see, all these 4 combinations are covered here, right? So the SOP here is A bar, B bar. Here I have A bar, B. I have AB bar here and I have AB here. So all the terms are covered. Then depending on whatever the output is for everyone, if it is 1, 1 or 0, 0, similarly we'll keep on putting this on a K-map and then see how to group them and reduce the equation. So this is for 2 variable. Say for example, I have a 3 variable K-map. So in 3 variable, I will have A, B and C. So how do we make such a K-map? We will have 8 different boxes here. So since here I have only 2 combinations, I'll put 1 variable here and I have 4 different combinations. So I'll have 2 variables here. So this is 0, 0. I'm sorry. This is 0. This is 1. Here I have 0, 0. I have 0, 1. Then I have 1, 1. And then I have 1, 0. So this form of coding is called as a gray coding. Why do we use gray coding? Because we don't want both the variables to change simultaneously, right? So ideally after 0, 1, I should have 1, 0, but 0 changes to 1 and 1 changes to 0, which means both the variables change. To avoid that, we are using gray coding. So if you see the first two terms, the first 0 remains same. In the second and the third one, the last one remains same, only one term changes. And in these two terms, the first term remains same and the last one changes. So in consecutive terms, one should remain constant and one is free to change, right? So this is how we cover all the 4 combinations, which means the min term that I can represent in this box is A bar, B bar, C bar, because all of them are 0, right? Here I can represent as A bar, B bar, C, because for C there is 1. So similarly, you can fill in all the boxes. Once you fill all the boxes, I just want to show you how those min terms decimal equivalent look like. So I'm just recreating another box here. So this is A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So decimal equivalent in which you will put the min terms will be decimal 0 here, 1 here, 2 here, and 3 here. And this is 4, 5, 4, 5, 6 here and 7 here. This is just because we are adding 1 1 here and then a 1 0, and that is why we have 0 1 2 3 4 5 6 7, right? So once given an equation, you know what min terms are available. Those min terms will be put here as 1. These are decimal places. These are not the numbers that you're supposed to put on a Kmap. Kmap, you will put either a 0 or a 1 depending on what the equation is, or what the truth table is. This is just to show which place which minterm holds. So decimal 1 minterm will be here, decimal 3 minterm will be here, decimal 2 minterm will be here, and so on and so forth. Lastly, I will do this for a 4 variable in an SOP form, and then in the next video or in this video I'll continue with the POS form. So a 4 variable K-map looks something like this. Since it is 4 variable, 2 raised to 4, which means it has 16 boxes, right? So I have two variables here, A, B and C, D here. So 4 variable we are considering as A, B and C, D. Now I'm not writing the min term. I will show you one of them and then I'll write the decimal equivalent for it. So 0, 0, 0, 1. Again here I have 1, 1 and then 1, 0. Similarly I have 0, 0, 0, 1, 1, 1 and then 1, 0. So for the first one I will write the min term A bar, B bar, C bar and D bar. I'll change the color. This is your decimal equivalent of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See here, 15 means 1, 1, 1, 1. That's the last number where we have all ones. If you see this row, all two ones, and this column, we have two ones, right? So this is how we represent decimal equivalent on the K map for the minterms. Then depending on the truth table or the equation, whichever minterm is available is put as a 1, which is not available is put as a 0. So now we move ahead with the POS form of the equation. The only difference between POS and SOP is for ones and zeros. If you remember our earlier lecture notes, see here, the min term is represented for 0 as a bar and for 1 as not a bar. And for max term, 0 is represented as not a bar and 1 is represented as a bar. So I'll quickly make those 3 K maps for 2 variable, 3 variable and 4 variable considering a POS form of the equation. So K map for POS. Let's start with the 2 variable. For 2 variables, I will have 4 boxes. So this is my A, this is my B, this is 0, 1, 0 and 1. So for this, how do we represent a max term now? We are talking about max term since it is POS equation. We'll be writing in max term form. So wherever there is 0, it is normal. So this is A plus B. Wherever it is 1, it is bar, which means it is A plus B bar. It is sum of the products, right? So this is your sum term. Then I have A bar plus B, and then last one you will have A bar plus B bar. So this is how you write a 2 variable K map for POS. Similarly, 3 variable will have 8 boxes. So this is your A, B, C, 0. I'm sorry. This is 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0. Decimal equivalent still remains the same. It is 0, 1, 2, 3, 4, 5, 6, 7. There is no change in the decimal form. But what you represent inside this box, that varies. So here now I have a max term which is represented as A plus B plus C. This will be A plus B plus C bar and so on and so forth. So depending on the equation or the truth table, whichever max term is available, we put it as 0. Max terms are represented as 0 on Kmap. On a Kmap, and min terms represent a 1 on Kmap. This is the difference between max term and min term. So if you have a min term in the equation, that min term will be represented as 1 on the Kmap, and max term if you have, that will be represented as a 0 on the Kmap. So 4 variable Kmap also remains the same. The decimal equivalent is same, only the POS form, the max terms inside it will change. So you have AB and CD. This is 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Decimal equivalent will be still the same. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this decimals will not change, but how you represent the equation will change. For example, the 15th one, max term will be represented as A bar plus B bar plus C bar plus D bar, because all are ones, and 1 for max term is represented as a complement. So you can check back to our lectures. For max term, 1 represented as complement, right? So this is how we create K-maps, 2 variable, 3 variable, and 4 variable for POS and SOP. So I will stop the lecture here. In next lecture, we will start with the numericals on this. Thank you for watching.